Video2Force, converting video motion to dynamic force feedback with event-based processing. In recent years, there is an increasing number of devices supporting haptic and force feedback available for VR applications. For example, Sense Glove, Tesla Suit, and Head Blaster. In VR environments, haptic and force feedback can significantly increase users' sense of reality and immersion. In this case, it is highly desirable to automatically render the haptic cues from the video motion in real time. However, there are some challenges to realize this automatic rendering. Firstly, it is difficult to estimate the force from the video motion. Secondly, since the video motion could be complicated and in a large amount, it is challenging to compute the force in a low complexity and provide users with real-time force feedback. Fortunately, the emerging event cameras based on the bio-inspired vision principle creates a new opportunity to address the above challenges. Instead of recording pixels at a fixed frame rate, event cameras only record the per-pixel brightness changes, called events, in an asynchronous manner. The advantages of event cameras over traditional cameras include extremely low data rates, low power processing, and they can record motion in a very high temporal resolution. By utilizing event camera and event-based processing, we propose Video2Force, the first framework that can automatically detect and transfer video motion into dynamic force feedback synchronized to the video motion. With Video2Force, the users can experience the virtual existence of the video motion while watching the video. In this research, we consider two kinds of motion for force estimation: object motion and particle motion. For object motion, we first estimate the object motion's velocity by tracking the object in event domain and calculate a force vector according to momentum theorem. For particle motion, we filter the event stream through an event size constraint and HOS filtering. Then, we estimate the particle intensity, which is rain intensity, in the event domain. We then determine the absolute detection threshold and monitor the rotation angles of the user's hands, and the final estimation result is converted into a dynamic force feedback on Sense Glove at a best efforts basis. We evaluate the effectiveness of Video2Force through quantitative experiments and user studies. While watching the video, users can simultaneously feel the dynamic force feedback transmitted by Sense Glove. For example, to experience the rainy scene, the basketball passing, and the boxing scenario. We have designed 8 video scenarios for our evaluation. We evaluated both the efficiency of our event-based processing and the user experience with Video2Force. Firstly, we compared our event-based tracking with some representative tracking methods, including 2 deep learning-based methods for object tracking. The results show that the tracking time of our event-based tracking can be an order of magnitude shorter than the traditional trackers. For event-based particle intensity estimation, our event-based method can be 2 orders of magnitude faster than the traditional method, that operates in pixel domain. Secondly, we adopted the iCrew presence questionnaires and VR experience metric to evaluate the user experience. The users will watch the videos in 3 conditions, including no force, static force, and dynamic force feedback on Sense Glove. Our results show that the dynamic force feedback of Video2Force could significantly enhance the user's sense of presence and VR experience. Overall, users have a stronger presence and better VR experience when perceiving dynamic force in the particle motion scenarios than in the object motion scenarios. In this work, we propose Video2Force, the first framework to render haptic cues by detecting and quantizing video motion automatically. Meanwhile, we propose novel event-based processing techniques to estimate the force from the video motion, including both the object motion and particle motion. Finally, we demonstrate the feasibility and advantages of Video2Force in converting the estimated force to dynamic feedback on Sense Glove, which allows users to experience the video motion while watching the video. Our work bridges, for the first time, the estimated video motion and the user's dynamic force feedback via emerging event-based processing, and the increasingly popular haptic supporting devices. Along this research direction, we believe plenty of opportunities can be exploited based on the idea, the framework and the techniques presented in this paper. In our future work, we plan to improve our force estimation to handle more diverse and complicated motion, and convert the estimated force to more forms of force feedback. We also plan to incorporate more types and higher precision haptic devices into Video2Force, to develop a more comprehensive framework. Thank you for watching.